tutorial starts with a song, but it's only a few seconds long.
Computer animation. Computer animation. Computer animation.
Let's get started with animation. Hello, this channel is approaching 400 tutorials. I'm glad I get so much response here. As long as it's useful, it's fine. I don't have time to give support. Simple questions I can answer, but I cannot go back to any kind of previous tutorials because I tend to forget them, really. They are more or less my private diary where I sometimes look up things. I'm only teaching here and studying. Today's tutorial will be very short and to the point. We're creating cloth today, nCloth that's called, because it's the Nucleus solver, and we concentrate on this value here, the input mesh attract. It's called input mesh attract. In other cases it's called goal weights and objects, with goal smoothness and with a goal active and the goal attraction factor between 0 and 1. And it's the same with the nCloth, it's just a different term. This is soft body dynamics, which we've covered in several tutorials today. We'll deal with nCloth. So let's start a new scene. So I create a polygon sphere. I think Cloth wants polygons, not NURBS surfaces. The higher resolution is, the more delicate the cloth is, so we can raise the resolution actually just a little bit. Subdivisions in axes is 20 by 20, so let's raise this to 30 by 30, which is quite high resolution really. And now we'll animate this, and in order to make it swing from left to right, we can just use a sine function. And this is more easy than you might think. Let's go to the polygon sphere here. It's that tab here which is responsible for where this object sits in the scene, not about what it looks like or not about how many subdivisions it has in the geometry. And since we want to let it swing in the blue axis, which is the Z axis, we need to check this value here. It's currently set to 0. Equals sine of time, and the time needs to be in parentheses. We'll edit this later because the swinging motion is too little. You will see this now. It's that tiny little swinging motion. Let's extend the frame range to 1000 so we can see what's happening here. And the pink color or the violet color means that there's an expression, that's the sine function. Edit expression with the right mouse click. And we need to extend that swinging motion by, say, 15, factor 15. So instead of swinging between +1 and -1, it swings between 15 and -15 now. We edit this, and now we have a much bigger swinging motion here, from left to right, within 1 second, one swinging motion. Now you need to go to FX, nCloth, very simple command. We don't need the option box here. And we see an N here, which means the nucleus. The nucleus provides the gravity. Now before we run the simulation, let us give it a new material now. For example, a Lambert shader, and we can give it the color blue, a light blue, like this. Okay, and now we let it swing. You see it falls down. It behaves like cloth, but it doesn't swing from left to right. Why is that? And that's the command I showed you at the very beginning. We need to go to nCloth because that's the dynamic section, and then we open the dynamic properties here. And under the dynamic properties we have all the default settings, and the default settings for the input mesh attract, that is how the original sphere attracts our cloth object, is set to 0 by default. When we set it to 1, this happens. We basically have the swinging motion from before. We don't see that it's a cloth object. But now while it's swinging, we can reduce the input mesh attraction And now you see not only how the cloth deforms, but you also see how long it takes for the cloth to recover, and that it slowly falls down. When we reduce this, it is affected much stronger by the gravity, but it always needs to return to the original as well. So it's sort of in between. When we reduce the input mesh attraction, it's totally undecided and it swings further down here. And since it's a cloth object, it behaves like cloth, of course. I want to show you something else which leads you to your own experiments here. Once you've achieved this, let's go a little bit further back here. So we have a swinging motion closer to the original motion. When we reduce the stretch resistance to 0, the material doesn't have a resistance against stretching. It will overstretch, which you see here. Creates interesting objects, certainly with UV problems when you render them, but that's the stretch resistance, and it's only one of about 10 parameters you can choose here: restitution angle, rigidity, etc. So when I change the stretch resistance to 100 or something like that, we get a totally different behavior. And with this, I leave you alone. Have a nice day. Bye-bye.